To find the distance over which a signal can be seen clearly in foggy conditions, a railway engineer uses dimensional analysis. He assumes that the distance depends on the mass density of the fog, intensity of light coming from the signal, and its frequency. His analysis shows that the distance is proportional to s to the power 1 over n, where s is the intensity of light from the signal. We are asked to find the value of n. As per the given information, the distance d can be written as proportional to the density raised to some number x and the intensity raised to some number y and the frequency raised to z. Now, according to dimensional analysis, the dimensions on either side of the equation must match. So if we start by looking at the dimensions of each of the physical quantities, let's say the dimension of density, the distance is L, and to get the dimensions of density, we know density is mass per unit volume. So the dimensions of density rho will be m over volume is like you multiplying length 3 times by itself, so L cube. Now, to get the dimensions of density, the problem has given its definition. Okay, so the intensity, to get the dimensions of intensity, the problem has given its dimensions. So the intensity of light is defined as power per unit area. So if you take intensity, now power can be written in two ways. Either you write it as work done per unit time, or you can either write it as 4 times velocity. So let's say if I use the force times velocity, divided by area. Now force is mass into acceleration, and acceleration is change in velocity by time taken. Again, since we are only looking at the dimensions, we can just write acceleration as velocity over time taken. So you already have velocity, so I think we can square the velocity. And then we have to write time and then area. I think this is good enough to get the dimensions of intensity. So the dimensions of intensity will be mass. Again, velocity is distance over time. So you have length square, and then time square comes to the denominator, and then already have a time. So that's dq. And then area is length square. So the dimensions of intensity of light will be mass divided by dq. Okay. Now for the frequency is number of waves emitted per unit time. Any number is dimensionless. So the dimensions of frequency is simply 1 over time. Now, by equating the dimensions on the left hand side and the right hand side, we get on the left hand side we have length, on the right hand side I have density dimensions, mass per length cube, and this must be raised to x. And then if you look at the dimensions of intensity is mass per time cube, and then this must be raised to 1, and then frequency 1 over time raised to z. Okay. Now, since we don't have any mass and time dimensions on the left hand side, we can just write mass raised to 0 and then length raised. So on the right hand side, we have m to the power x plus y, and then if I look at the length dimensions, it is l to the power minus 3x. Then the time dimensions are t to the power minus 3y. Now, equating the dimensions of length, we get minus 3x as 1. So x is minus 1 over 3. And now, if you equate the dimensions of mass, so x plus y is 0. So y is 1 over 3. And then if you look at y, okay, so y is basically 1 over n. So the value of n will be